Saxon's Trig, lesson 67, is only about anti-logarithms, beginning on page 426. So anti-logarithms, you're obviously working the problem backwards, and let's just jump into example 1. If the base is 2, find the anti-logarithm of 4.63. So that means you are giving it the exponent of 4.63, and that's what you're supposed to work out. Now, this is just a calculator kind of a problem, but they do say that you should estimate the answer in your head to make sure that you've not punched in something incorrectly on the calculator and gotten a wrong answer. So figure out what 2 to the 4th power is and make sure that the calculator spitting out something is close to 16, and it should be higher than that. And they do say if you test 2 to the 4th is 16 and then 2 to the 5th, you get 32. So the answer is falling somewhere between 16 and 32. I would say because this is more than half, you can estimate a little bit closer, but again, it's just a rough idea in your head. So what you want to do is find on your calculator a y to the x or an x to the y, something where you are allowed to put in a base number and an exponent number. And once you find that, depends on whether it wants the exponent first, then the base, or the base, then the exponent. Every calculator is different. Once you figure out how that works, the answer your calculator should be giving you is 24.76, or pretty close to that. Now, example 2. Use a calculator to find the anti-logarithm of 4.63 if the base is 10. So now we have 10 to the 4.63. I can again use that same button. However, because 10 is based on a log, in your log button, you may automatically have a 10 to the x, or it's probably 10 to the x, not 10 to the y. And you can straight up do that rather than the y to the x or x to the y button. And it may also be like a shift or inverse of the log button. It may be embedded in like that upper menu where you have to shift or hit inverse and then the log. Because the base is 10, using that log button will work. And again, when you figure out how your calculator works that, you should be getting 42,000, yikes, 657.95. And that's going to be pretty big because I know 4 to whatever power, that's climbing really quickly. Example 3, use a calculator to find the base e anti-logarithm of 4.63. So now it's e to the 4.63. Again, I will have an e to the x button. It's probably above the natural log button, so you might want to do inverse of natural log. However, your calculator wants you to put it in there, you should be getting 102.51. So the bulk of this lesson is basically you playing with your calculator until you're figuring out how it wants you to plug these things in. Example 4, write the value of e to 5 decimal places. Oh, okay. Well, e, if you want it in 5 decimal places, you're implying a 1 for its exponent. So again, either e to the x button, inverse natural log, however it's going to do it, you're looking for 2 point and then 5 decimal places. So 71828 is what happens if you're rounding it to the 5th place. And again, I don't remember if early on in one of the videos I said, but they have had calculators who have tried to program out pi, and it just keeps going and going and going. The same thing is happening with e. It's another one of those irrational numbers that just don't quit. And so your calculator will just, it can only show you so many digits, but a high-powered computer can show you a whole lot more. Final example 5 says estimate the anti-log e to the negative 3.2. So that's basically asking you to do e to the negative 3.2. Now, you can just program that into your calculator. If your calculator would be giving you an error because it doesn't like the negative with the e, remember that you can change its location. and that changes it from positive to negative. So it goes from numerator down to denominator, and it's no longer negative. You can do e to the 3.2 and then do 1 divided by that decimal, but however you are able to do it, you should be getting 0.04076622, and I would never have carried it that far. I would have rounded it off probably to 2 places and kept my answer at 0.04. But now you know how to play with your calculator till you get it giving you those numbers.